Hello, let's continue our Sudoku adventure with Penthouse by Matt Tressel. So this is the final puzzle of our celebration of hitting Sudoku Adventure 1000. I hope you enjoyed our kind of reminiscing about the past and being inspired by puzzles of the past. And so for the rest of November, we'll be on our normal rotation, but then December, from the 1st to 25th, is always a holiday theme. So expect a bunch of holiday puzzles in December. All right, so let's go over the rules to this one. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have hidden skyscrapers. I call them hidden because we have to figure out what their value is. So whatever digit we end up putting outside the grid, which is not limited to 1 to 6, by the way, although I guess with the skyscraper, you are limited to 1 to 6. But anyway, we're putting a digit outside the grid, and that is going to be the value of our skyscraper clue. And we must put a digit in each of these cells that's outlined in gray. So how does that work? Well, let's say we put a 4 here. What this represents is the count of the number of skyscrapers that you can see from that vantage point. Or if you prefer to be a little bit less dry, or to be a little bit more dry, I should say, it's the count of the digits starting in that direction that are larger than all the previous digits. So we're always going to see this one. Say this was let's make it a 3. Let's say this was a 3. You're always going to see the 3 because you always see the one right in front of your face. There's nothing to block it. But then if the next digit was a 2, we can't see the 2 because it's not bigger than the 3. Then let's say we could do a 4. 4 is bigger than 2 and 3, so we see it. So let's just green the ones we see, gray the ones we don't. Then we could do, say, the 1 here. The 1 is smaller than the 4, 2, and 3, so we definitely don't see that one. Then we could do, say, 5 and 6, and we see both of those because 5 is bigger than all the previous ones and 6 is bigger than all the previous ones. Now we count how many green cells we have, 1, 2, 3, 4, and that is the 4 clue. So this would be one way to fill this row here. All right. In addition to that, these purple thermometers are consecutive thermometers. So basically, the smaller digit goes in the bulb. So if this is a 4, the smaller digit goes there. And then we have to increase by 1, exactly 1 as we move along. So normal thermometers, you just have to increase. But consecutive thermometers, we have to be bigger. So basically what this is saying is these digits are all consecutive with each other with the smaller digit going in the circle. That's all these are. So 4 would put 5, 3 would put 4. That's all forced. 5 would put 6. All right. Now, this puzzle was inspired by Duplex, which was number 948 by ChinStrap. Matt says, I really liked the interactions of the 2 cell lines that were used for both clues and digits in the grid. All right. Well, there is a link in the description if you would like to try the puzzle yourself, and I'm going to get started right now. All righty. So what is our... So all these clues, I think there's a few things to talk about with skyscrapers before we kind of do anything else. First is you can't do a 1 skyscraper because the only way a 1 okay, so we can do 1 skyscrapers, but the only way that works is if there's a if there's a 6 next to it. Right. Sorry. If we have a 1 skyscraper, we must have a 6 right in front of our faces because it has to block everything else in the row. I got confused about what we were doing for a second. And so that wouldn't work here because they aren't consecutive. So this can't be a 1. And now a 6 can't go in any of these bulbs because the next one has to be 1 bigger, and we don't have a 7 in the puzzle. So our options for the ones that go straight into their row or column are 2, 3, 4, 5. Those are the only options for those. And that means the ones that they go into have to be 1 bigger, so they have to be from 3, 4, 5, 6. Now, that exposes that some of these combos just don't work, right? The most obvious is 5, 6 simply doesn't work. The 6, you're only going to see the 6. You're going to hide everything else. That does not account to 5. So 5, 6 does not work. So we can go through all these and remove 5. We can go through these and remove 6. I forgot I can double click. All right. Now, 4, 5 also doesn't work because we'd see the 5 and the 6. Exactly. It would have to be a 2. And so we're not doing 4, 5. Now, 3, 4 just barely works. We'd see the 4, the 5, and the 6. So we'd have to put the 5 and 6 in order, but otherwise we're fine with 3, 4. 2, 3 is quite possible. You just need to see the 6 before you see anything bigger than 3. All right. So, and we are going to have some 2 3s because we have these 3 4 pairs, which makes this like a 2 3 pair. So one of these is 2, one of these is 3. Same thing here, same thing here. Now these are much less restricted because we just have to worry about what's right in our face. So we just know they aren't 6s. They're 1 2 3 4 5. I'm not sure if I want to do anything penciling with that yet. I think what I want to do is color these 3 4s. So this is, we'll just call this green and call this, I normally use purple, but today I'm going to use orange and blue because we have purple constraints. So we don't know if this is 3 or 4, but whichever one it is, we'll call it orange, and then blue is the other one, right? If this ends up at 3, this has to be a 4. That's what we're representing. Excuse me. So in this row, in fact, I need water. I apologize. All right, so this is going to be orange. This is blue. This is orange. This is blue. Using this column, this is blue. This is orange. So we know that all the oranges are either 3 or 4, and all the blues are the other one. So is there anything we can say about that? Maybe we can actually place some more 3 4s. Blue. Yeah, so this is the only place for blue in this whole box. This is the blue 3 4 because this blue looks in, this blue looks up. So we have 3 4 3 4. Blue is here in this box, 3 4. And orange is here and here, which we can't quite resolve. Now I wonder if the problem is 2 3 is pretty. Well, okay, so each of them have their own kind of esoteric, I don't know if esoteric is the right word. They each have their own requirements, right? The 2 3 requires that we see the 6 before we get to a 4 or a 5 or a 6. Or sorry, before we get to 4 or 5, we need to see a 6. So if this was 3 4, sorry, if this was 2 3, we got to see the 6 before we see anything bigger than 3. And if this was 3 4, we just have to make sure we see the 5 before we see the 6. So we know that one of these two is the orange 3 4. If this ended up the orange 3 4, I think that proves that this has to be the 4. Because if this was the 3, we would see the 4 before seeing the 6, and we'd have a count of at least 3. So if it ends up here, then I'm not saying it does, but if it ends up here, then this has to be the 4. I wonder if I do need to use these in some way. I don't know how I would. Let's see. So let's just blindly pencil this as 1 2 3 4 5, and that makes these 2 3 4 5 6. Now we know this can't be 3 or 4 because it sees the 3 4 pair in the row in the column. And so that means this can't be 2 or 3. Now 1 would require 6 here. 5 would require 6 here just by the constraint. 4 5 is interesting. Can we see 4? Okay. 5 is not possible here because we're never seeing these 3 4s over here. The skyscraper cannot see these 3 4s. The 6 is going to be somewhere in these 4 cells, and it blocks the rest. And so we only have 6 cells that we can see in total. We're not seeing these 2, so this cannot be a 5. Now 4 would require this to be exactly 1 2 5 6 in order to see all 4 of them, because again, we're never seeing this 3 4. The 1 would require this to be a 6. So the conclusion we can at least make is this cell is 1 or 6. And this is 2 or 5. Oh, actually, no, it worked. Wait. No, it doesn't work. Okay, sorry. Let's go back to the case of 4. In the case of 4, we have to do 1 2 5 6 because the 3 4 is gone. And now there's no value for here. We wanted to put a 5 here. That repeats the 5. Or you can think about the other way around as well. But that makes this 1 and 2. And that forces this to be 6 because a 1 requires a 6 next to it. Okay. So we know this is a 2. And we know the 6 is up here somewhere. In fact, this is just, sorry, it's 1 5. And so this is 1 5 6. Okay. Let's look at this now. We're never seeing this guy, I don't think. Let's see. No, that might not be the right way to think about it. That might not be true. Um, I'm trying to think about this right, but I'm not sure how. Well, we know this isn't 3-4 because of the 3-4 pair here. So this is not 2-3. 1 would require 6 here, which seems reasonable. That's exactly what happened here. I'm trying to think if 5 is not possible. We would need to see... Oh, this can't be a 6. Okay, maybe that's key though, because in the column, like this is a 1-5 pair for the column. So this is never going to be a 6, which means the 6 at its latest is here, which means we can't see more than 4 digits. Just by looking at the 6 placement, we're never seeing these two. So that's not 5, that's not 6. Now let's see if we can eliminate 4 again. So this would have to be 6, and these would have to go in order. So we could do like 1, let's see, if this was 4, this would be 5. So we'd hide the 5 over here. Yeah, I think it works. I think we can do, let's see, I think we can do 4, 5. And so we would hide the 5 over here. This would be our 6. And then this would be the 1-2 pair. This would be 1-2. So we'd see 1-2, we'd see whatever this ends up being, and we'd see the 6. So that actually does work. It forces quite a bit, but it does work. A 1 would put a 6 here. So we know this is never 6. The 6 ends up here or here, depending on whether this is 1 or 4. So if this is not 6, it's also not 3-4. It's from 1-2-5. Okay, I don't know if that deduction was useful. I might have missed something about it. Is there one of these that I can like... The 6 ended up really far away here. So wasn't there an issue with the 2? Yeah, okay, this can't be a 2. That would make this a 3, and this would be a 4, and we'd see 3, 4, and 6. So this is the 3, and that actually tells me the values of all the oranges. That probably would have helped to see a long time ago. Those are all 4s. These are all 3s. These are all 2s. Oops. Connected to the blue is 2. All right. Connected to the orange is 3. And I don't need the colors anymore. All right. Did that help at all? We know this is 2, 3. So this has to... We have to see the 6 before we see the 4. So this is where the 4 goes in the box. Do we have any more like that? Yeah, so after the 2, 3, we have to see the 6 before we see the 5. So this has to be 1, 5. 3, 4. Okay, we saw the 5 before the 6. That works. We just have to see the 5 before the 6 here. So this can only be a 1 or a 2. Oh, it can't be the 2. So this has to be the 1. And then now we have to see the 6 before we see anything else. So we have to put the 6 here because we don't have the 2 to pad it. That's 5. And then this ends up being the 4. Okay. I think the 2 3s are kind of key here. This can't be 1. This could be a 2. Hold on. What kept this from being a 6? Sorry, I might have jumped the gun there. This is a 1 or a 6. I was thinking if this wasn't a 6, it would have to be a 1, and then I kind of just went with that. That wasn't right. This can't be a 1, so this is a 2 or a 6. We can always get the 6 right after the 4. But here also, this is 1, 2, or sorry, it's not a 1. This is 2 or 6. Because this needs to see either the 2 or the 6 next as well. No, I'm not. The 3, 4 isn't doing that. Oh my gosh, hold on. Let me back up. It's the 2, 3 that does that. Oh my gosh. I was doing so well, and now I'm kind of messing up this puzzle. Anyway, after the 2, 3, we have to see either something smaller than 3 or we need to see the 6. The only thing smaller than 3 left is the 2, so it's 2 or 6. After this 2, 3, we can be 1, 2, or 6. Okay, I'm just trying to catch all the 2, 3s, and I'm having a tough time for some reason. All right, now the 3, 4, we're not allowed to see the 6 before we see the 5, so this cannot be 6. That's the only deduction. So it's not 1, it could be 2, it can't be 3, 4, it could be 5, it can't be 6, because 6 would ruin our skyscraper. Right, this 3, 4, okay, so after this 3, 4, this cannot be the 6, because we need to see the 5 first. So this is a 2, this is a 5, that's a 6, perfect. That's 1 and 5, that's 5, which makes that 4. by the constraint, the little purple thing. That's not a 5. This is 1, 2, 6. So this is 2, 6. No, not 6. It's not 1 or 6, so it has to be a 2. So that's not a 2. I want to look at this here. Can this be a 1? This could be 1, 6 or 6, 1 either way. It's just a 1, 6 pair. Is there another skyscraper, or do I just need Sudoku? This is 1, 6. This is 1, 2, 6, not a 2. So 2 in this row can only go here. This is 1, 5. No, it's not a 1. Sorry, that's 6. Sorry, that's... What am I doing? This is 5. I'm just trying to wrap up this puzzle. We get the 5 here. This is 4. This is a 1 or a 6. This is a 2. And now these 1, 6s have to be resolved by one of our skyscrapers. Which one does it? I might have to go through one at a time. Oh, maybe it's this 4 here. Oh yeah, we can't put a 6 next to the 4. That doesn't work. So that's 1, that's 6, that's 1, that's 6, 1, 6, 1, 6. And we're done. All right. Cool puzzle, Matt. I don't know why I just kept messing up the logic of that. It's a little bit intricate, and I just kind of lost the thread for a little bit, but we got there. Cool. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.